We're going to look at the concept of movement in this activity, and we're going to start by looking at our learning intentions and success criteria. Our learning intention for this is to know how to control software with hardware, and our success criteria will be that we can turn motors on and off using the MR5. We can make motors drive in two different directions, and we can record the MR5's GPIO pin configuration in our documentation. Like the LEDs, the motor GPIO pins are set and the same on every single MR5. Having said that, different motors are powered by different pins on different MR5, so that they are the same 4 pins that you use, but those 4 pins could control anything. For example, 6 might be forward on left, while 13 might be backwards on right. But the 4 pins are 6, 13, 19, and 26. At this point, it's fair to warn you that you will need to have your MR5 running on the floor. My demonstration MR5, when you see it in my videos, runs on a table, but that's me doing it, and I've got a very controlled environment. In fact, I've got a pillow just in case it falls off the edge. These robots can at times just start driving, and it's very hard to stop them. We don't want them driving off the table. Please ensure that your MR5 is on the floor for this activity. Also be careful you don't step on it. The wiring to run a motor out of a microcontroller like the Raspberry Pi is a little bit more complicated than an LED. You'll see there that the Raspberry Pi, the green section down there, has 2 wires coming out of it. One out of pin 6 is the blue one, and pin 13 next to it. Don't ask me why they've numbered it that way, that's how they have. The purple one next to it is pin 13, and they are going to this thing called an L298N H bridge. And basically that then feeds into the motor. The main 2 reasons for this are that number one, that the Pi runs on 3.3 volts, while the motors in our MR5 run on 6 volts. But the bridge could handle up to 30 volts. So you can drive a 6 volt motor from a 3.3 volt device using one of these bridges. What it does is it steps up the voltage. So there's actually a battery, 6 volt battery on the MR5 that plugs directly into the bridge, and the 3.3 volts goes in and it steps it up to the 6 volts when it needs it. The other reason is that your motor actually acts as a generator. And if you think about it, those big windmills that you see on the side of the highway when you're driving along generating electricity, they are just motors, and if the motors are caused to spin, they create energy going backwards, and that energy going backwards into the Raspberry Pi could damage it. So we need this bridge to stop those 2 things from happening, or to enable one thing to happen and to stop the other. The way that this works is if you set GPIO pin 6 to high and GPIO pin 13 to low, the motor will move in one direction. Let's just say, as an example, that it'll move in a clockwise direction. If you swap those 2 around, so now the GPIO 6 is low and the GPIO 13 is high, the motor will move in the opposite direction. Therefore, it will move anti-clockwise. If you set the pins both to low, or if you set the pins both to high, the motor won't turn at all. It'll just sit there basically doing nothing. There is some slight differences in the motors that will actually occur when you set one both to low and both to high, but that doesn't matter for these particular motors that are running in the MR5. When we program our motors, it is exactly the same as programming the LEDs. You need to be able to go through the four different GPIO pins and make some notes as to which one it is. You can see in the code that I've done here, I've worked through and I've created a comment. This is a general comment that's not attached to any code that I just keep up in the top corner for my own reference, and I right click to create that comment. It's like a sticky note that sits up there And I can drag it around if I need it. I can minimize it if I need it. But it tells me that 6 is right forward, 13 is right reverse, 19 is left reverse, and 26 is left forward. And I'll walk through to do that. As a warning, when you do this programming to figure out what it is, you'll notice that I've got 30 seconds. You don't want the robot running for 30 seconds. You really only need it for 1 or 2 seconds to do that. If, say, for example, you set 26 to be high and you forget down the bottom to also change that to low, the robot will pretty much run like that forever. As soon as you set the GPIO to high, the motor will start spinning. So you'll need to be aware of that. And if you can't stop it spinning by changing the settings in the programming quickly enough, simply turn the robot off. Start again. You'll have to restart it. It will take a while, but you need to try and avoid doing that. I typically like to set my pin numbers low before I set the pin numbers high and make sure my programs are all connected. Another thing I do is, once I've actually programmed it up, is I create an emergency brake. So that in this case, when I press the space bar, all of the GPIO pins get set to low. See how I've used the comment there? That basically happened when I right-clicked on the orange section and it attached, you can see there's a line there, it attached that comment to my code. That way I can understand what that does. As an emergency brake, if my robot's ever running away, all I need to do is press the spacebar and it will stop doing what it was doing straight away and put everything to low. Once we've done that, we can create a whole bunch of moves that we can do. So for example here, on the up arrow, we're going to make it move forward, and you can see by my comment that I'm going to make it move forward by setting 6 and 26 to high. If we go back here, we can see that right forward is 6 and left forward is 26. So if both motors are moving forward, the whole robot will go forward. In order to complete this to a satisfactory level, you need to record all GPIO motor pins on your particular MR5. If you have a different one, they will be different, so you probably should go through and do all the LED pins as well. You'll need to make sure that your robot can move forward, backwards, turn left and right with the arrow keys. And you need to ensure that your robot has an emergency brake function, for example on the spacebar. For commendable, you need to make it such that when the user presses the S key, the robot drives in a 1 meter by 1 meter square pattern. So it drives around the perimeter of a square. You need to place a marker where it stops, and it must stop within 20 centimeters of the marker after completing all 4 sides of the square. So it needs to go about a meter, then turn left, then go about a meter, then turn left, then go about a meter, then turn left, and end up within 20 centimeters of where it started. To get exceptional, you need to use sprites on the stage to allow the user to drive the robot using a mouse. There will be no hints about this. You must figure out how to do it yourself. So that's the activity that you need to do. You need to go through, you need to use comments as much as possible and work through to create a robot that you can start to control using the keyboard or even the mouse and using the emergency stop function.